Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, so I'm sharing my screen there, but if you're at home or you're watching this recording, you can always follow along on your test. So let's get going.
Oh my god. I think my computer overheated. Feel it. Feel it. Oh yeah, that's one way.
Okay, number one. Oh, did I finish taking? Okay, calculate the slope of a line. So here's the 2 points. We're going to calculate the slope of between these 2 points, 4, -3, and 4, -5. Tell whether the line rises, falls, is horizontal, or vertical. Okay, so you could graph these if you didn't want to use the slope formula, and then you could probably know right away 4, -3 is right here. 4, -5 is right here. So this is what the line looks like. So the slope is actually undefined. M equals undefined. And so it's vertical. So there's 2 parts to this question. Make sure you answer all of the question. This is where these tests get you guys. Like you do great math and then you forget to answer a question. Okay? So there's 2 parts. Tell the slope and whether it rises, falls, is the horizontal or vertical. If you wanted to use a slope formula, it's just M equals difference of y's over difference of x's, right? Because y's measure rise and x's measure, I wanted to like rhyme, rexes, I don't know, run, okay? So this is rise over run. So -5 minus -3. But then you got 4 minus 4, and that's going to be something over 0. So this is undefined. Anything divided by 0 is undefined. Okay? So if you graph it, you can see that it's vertical. But if you have an undefined slope, remember that is just a wall. It's not even a slope. It doesn't even make sense to call it a slope because it's not, that's not a road you can go up or down. It's just a wall. So the word undefined kind of makes more sense. It doesn't even make sense to call it a slope. So a horizontal line has a slope of 0. If this was 0 over -2, it would look like that. And that's a slope of 0. Okay? That makes sense, at least, to call it a slope or no slope. Okay. Everyone good with number 1? I would do both. Do the slope formula and graph it just to make sure you're answering it correctly. Okay, number 3, we're going to divide x plus 3 into this big long.
What about number 2?
Oh. Can we come back to number 2? Because I don't want to like erase that.
No, you have to erase it. You have to start.
Yeah, I really can't do this. I really can't.
Well, I'm missing my mic already.
I know you're kidding, but I agree with you.
How can you
So,
without being able to count right?
It was a joke.
I'm going to go to number 2 here.
Okay. Well, now that just looks really off.
Oh my
I know. Okay, 4x squared minus 5x equals 6. All right, we're going to find the roots. This is just solving a quadratic equation by factoring. So if you look over here, steps to solve quad EQs by factoring. So finding the roots mean what equals 0. Okay, so we're going to bring this guy over here. That's the first step. Write everything on one side with 0 on the other. right? So a positive 6 on the right becomes a negative 6 on the left, right? Okay, then we are going to follow the steps to factoring. Now, unfortunately, there's no GCF. Nothing goes into 4, 5, or 6, and there's not x's in all of them. There's only x's in 2 of them. There's not a difference of 2 squares. That's always easy because if there's 3 terms, that's not 2 of anything, right? It's 3 of something. Number 3 is look for a factorable trinomial. I think we've got one, but unfortunately, it's not like the x and the x. Now, and it could be 4x and x, or it could be 2x and 2x. So see how our number of possibilities greatly increased. I'm thinking that the 4x and x is going to make something a little too big, maybe not. So let's try the 2x and 2x first. Okay, and then let's just try some factors of negative 6. What factors do you got? 2 and negative 3 or negative 2 and 3? Which one do you want to try? Negative 2 and 3. So when I FOIL this out, this is just me trial and erroring, okay? So remember, these two numbers have to multiply to get 4x squared. These two numbers have to multiply to get negative 6. And then foiling it out has to somehow miraculously end up with a negative 5, okay? So I'm going to FOIL it out. I already know that 2x times 2x is 4x squared, so I don't even need to write that. But then I get, let's see, 6x, and a negative 4x, and then a negative 6, which I already knew. So really, you're just checking the outside and inside. That doesn't work because you have to end up with the 5x. Even reversing it won't work. Okay, so what else do you want to try?
Can I give it an idea?
Yep.
Okay, so I put x minus 2 and then 4x plus 3.
Okay, so you did x, instead of 2x and 2x, you did x and 4x.
Yes.
All right, let's try that. So we may come back to that 2x, but, and what'd you say?
The first one is minus 2 and the other one's plus 3.
Okay, that's going to do it. Because look what happens. You get 4x squared, which you already knew, but then you get 3x and a negative 8x. What does that combine to? Negative 5x. Very good. Okay. So it's gonna. There's another Saxon method. If you like multiply these together and then do this weird stuff, there's an algorithm you can follow to figure out what that combination is. But I think it's faster, honestly, to just go through your head all the different possibilities, or you can write them down. Trial and error is sometimes faster than following some method. Okay, that's number 2.
And
You guys okay with that?
If that's just the answer, the x minus 2 or just
Yeah, yeah. So the roots. Sorry, didn't even finish.
Isn't it like 0 or something?
Yeah. So what? The last step to factoring is set each factor, or parenthesis in this case, to 0, and then solve. So x minus 2 equals 0, which basically x equals 2. And then also 4x plus 3 could be 0. So solve that. The shortcut is opposite of that sign, this number over this number. But if you don't remember the shortcut, just set that to 0 and solve it. You're going to end up with a fraction, minus 3 minus 3. So 4x equals negative 3. Divide by 4, x equals negative 3 over 4, negative 3/4. So those are the 2 roots. Roots are basically what makes that 0. Or roots are really just solutions. So these 2 numbers satisfy that equation. If I plugged in 4 times 2 squared, so 4 times 2 squared is 16, minus 5 times 2 is 10, 16 minus 10 is 6, that works. Negative 3/4 squared is positive 9/16. So then you get 9/4 minus plus 15/4 is 24/4, which is 6. Minus 6 is 0. That works. Okay. Number 3, we're dividing this sucker. X plus 3 into this big long equation, x cubed, not equation, but polynomial, minus 9x squared minus 29x plus 21. Okay. This one is, remember, if you're missing a variable term, then you need to put 0. Like if you're missing the x squared, you need to put 0x squared. But you're not. You're good. So now we're going to dirty monkey smell bad. So remember, the first step is divide, and you're just dividing the first terms only, which is different than normal long division. You have to account for that second term, or at least as part of your guessing. Okay, but you still multiply both terms when you get to that step. So x cubed over x, you're just always taking away an x, right? So divide an x out of x cubed and you get x squared, right? Next step, multiply. And usually you're multiplying a single term times a binomial. So you're going to distribute. So this becomes x squared times this whole thing, x plus 3. So then you'll get x cubed plus 3x squared. Right? So far, so good?
Yeah.
All right, next step is subtract. Now this is the weird one. Now the first term will always cancel. So you can just ignore the first terms. So you're just subtracting a positive 3x squared, which is just normal. I would suggest just chicken scratching, because a lot of times you will be subtracting a negative and that's confusing, right? So subtract that. Negative 3 and negative 9 is negative 12x squared. Last step, bring down the next term. So dirty monkey smell bad. D, M, oh, that's a new one. SB, bring down next term, and then start over. This is a lot like normal long division. Instead of bringing down terms, you're bringing down digits. But those are really terms because they're place value. Now start the process again. Divide just the first terms. So negative 12x squared, divide out an x. You're just taking away 1 from that exponent. So it's just negative 12x. Next step, multiply. You can probably do that. You don't have to write it out like this. You could probably do it from here. Negative 12x times x is negative 12x squared. Negative 12x times positive 3 is negative 36x. Last step, or before you bring down the next one, subtract. So remember, you can just ignore that first term because those will always cancel. So minus 36x. What's that? Plus positive 36x combined with a negative 29x. What is that? 7x. Good. Last step, bring down the next term. Plus 21. This is going to end up real nice, I think. So now repeat the process. Just divide an x out of 7x, and you get a 7. Distribute 7 times x, 7 times 3, 7x plus 21. Subtract. Everything's the same. No remainder. There's your answer. Does that feel okay? Doable?
Yeah.
All right. Good. Here, let me just tell you if there's going to be a remainder on this test. Would that be helpful?
For sure.
Oh, don't look up there. These are all the answers.
That's what I need.
Don't we all?
Write the answers to one.
What is that, number 3? No remainder. Yay. Okay, number 4. Move on. All right, number 4, solve this equation. 4 times the absolute value of 3x minus 5 is less than or equal to 5. Okay. So our goal is still the same. We still have to get our variable by itself, but in an absolute value equations, we have to first get what's happening. Okay, you have to first, step 1 is to get, and write this down if you need to, get absolute value cage by itself. Okay, so we have to get the cage by itself, and then we can break them out. So this is, just treat this as like a really chubby variable. It's kind of like 4b minus 5 is less than or equal to 5. So what do you get rid of first? Let's get rid of the 5. Add 5 to both sides. So then we get 4b. It's less than or equal to 10. Now, what else do you have to get rid of? The 4. Get rid of 4, which is being multiplied, you divide. See, everything is still the same. We're just ignoring our problems and moving on with our life here. Did I copy the problem down right?
Mm-hmm.
All right, that's a pain in the butt, but whatever. So that's 5 halves. Just reduce it. If you can't divide it, at least reduce it. All right, now when you get to that, second step is make 2 equations. Okay, one is less than, and then one is greater than the opposite. Okay, or in this case, it would be less than or equal to. So we're going to make 2 equations here. And so this is 3x. Make 2 equations without cage. 3x is less than or equal to 5 halves. Okay? That will always be, just rewrite it exactly the same way without the absolute value symbols. And then the other equation is write the left side the same, flip the symbol, and negate the right side. So it's, in this case, I wrote that, and then I have to decide whether this is an and or an or. Well, if it can't be less than that and greater than that at the same time. There's no overlap there. So this has to be an or. Okay? But you'll see once you graph it, it'll be easier to see. Oh, it doesn't say graph it, but we're gonna graph it. Oh, it's not or, it is an and.
Yeah.
Because it's greater than a negative and less than a positive, so there's overlap there. Okay, so last step to solving these inequalities is what? Divide by 3, right? So when you divide a fraction by a whole number, you're just multiplying that denominator. If it makes you feel better, you can divide by 3 means multiply by 1/3. So multiply the 3 times the 2. So this is x is less than or equal to 5/6. And x is greater than or equal to negative 5/6. So on a graph, it would look like this. So negative 5, 6, 5, 6, shade in the middle, and they're less than or equal to and greater than or equal to, so shade them in. Fill them in. Now, this is a conjunction. You can always write a conjunction like this. You can put the lesser number here, negative 5, 6, less than or equal to x, less than or equal to positive 5, 6. So that just saves you the time, and you can write it as one nice little statement instead of two with an and in the middle. Just what a conjunction does, right? You can either write two sentences when you have a conjunction, or you can combine it into one. I have an ugly sweater and I'm attractive, which is kind of weird, but I know.
It's crazy how it works.
It's crazy. All right, that was number 4. It was a little tricky because of the fraction. Fractions always literally F things up, fraction them up. Okay, so we're going to graph this for number 5. We're going to graph 3y plus 3 is greater than x by making a table of values. All right, you could do that, I guess. So pick some x's and y's. When you have x by itself, it's probably better to pick some y's. So pick a y.
0.
0. If y is 0,
X equals 3.
x is, yeah, so 3, but later we're going to dot that line, right? Because it's greater than. Okay, and then let's say y is 1. That makes that 3 plus 3 is 6. Maybe it's like negative 1, then x would actually be 0, right? Negative 3 plus 3 is 0. So if I graph that, it looks like this. 3, 0 is right there. 6, 1 is right there. 0, negative 1 is right there. And it's dotted. So now we have to decide whether we shade on top or shade on the bottom. We're going to shade on top or shade on the bottom. Because we don't have like a nice little y is greater than or y is less than something, right? So how do we know how to shade?
Still the bottom, though, right? Because y is.
Yeah, so what I normally do is I just pick the origin and I see if that is true for this equation. So if you plug in zeros for the variables, you get 3 is greater than 0. Is 3 greater than 0? So it's true. So that means I'm going to shade on top. Did I do something wrong? So if I did it this way, this is the way that we that I like to do it, is just put this in slope-intercept form for the love of Pete. So this is 3y is greater than x minus 3. Divide by 3, y equals 1/3 x minus 1, or y is greater than that. So see how you're shading above this line and not on the line. Okay, so if you want to do it both ways, you can. But take your points, and that's great. But then pick a point that's not on that line and see if it works in that equation. If it makes that, or inequality, sorry. If it makes that inequality true, then shade where that point is, where you picked. The 0, 0 is always the easiest one. So I'd recommend that. Okay, all right. That was number 5. Let's do number 6.
That's it. Okay.
So yeah, you're graphing, right? Just says graph.
I didn't do that one. I skipped that one.
Graph by making a table of values. Do you know how to do it now, though?
Yeah.
Okay, good.
I just did it at 10 ticks. It was like already like 9:47. I'm like, yeah.
Yeah.
I'm just skipping it.
And you only have to do 15.
Yeah.
I hear you.
Yeah. Yeah.
Aren't I gonna have time to look at
Make sure you know how to do it, though. If you should definitely do the ones
That's
you're not.
why I waited till today.
Okay. Because that's the whole point, is you're practicing, right?
Yeah.
Number 6.
Yeah.
Write the equation of the line that is parallel to the graph of y equals negative 6x plus 7. So parallel to y equals negative 6x plus 7 and crosses the point 2, 5. There's several different ways you could do this. What do you guys want to do? I can think of 3 right now.
Which one? First one.
The first one, choice
What are my
A.
I
options?
prefer the second one.
Thank you. Wait, what was the question?
No, which
Said
way do you want to do this? There's 3 different ways.
The
I said
easiest way.
what? The first one.
Okay, I think that there's an easiest way if you remember this formula. Point slope formula.
That's not the easiest way. Yeah, remembering formulas is not easy.
Okay, well, you don't have to do that. That's option 1.
It is when you're in physics, right?
Option 2 is you can, let's see here, just slope intercept. Slope intercept. And number 3 is just graph it and hope for the best. What do you want to do? What do you want to try?
Slope intercept.
Slope intercept? Okay. So here's the deal.
Number 1.
Number 2. So we have to write an equation.
Is that the easiest one? Did I pick wrong?
No, this is what I normally teach is number 2, but this point slope formula is easier if you know the formula, but it kind of takes your brain out of the equation, and I don't like that. Okay? So number 6 is write the equation. So the equation of a line looks like this. Y equals mx plus b, right?
Yeah.
So what does m stand for? Slope. And what does b stand for? Y-intercept.
Yeah.
So do we know the slope?
Yes.
What's
Yeah.
the slope?
-6.
-6. So basically, this is who cares?
Oh.
Because this line is not the line we want to write an equation for. That would be silly because the equation's right there. This is just parallel to that line. So this 7, that's where that line crosses the y-axis. But we don't care about where it crosses the axis. We only care about the slope. So now we know the slope. Okay, so y equals -6x plus b. Now we need the b, and then we have our equation. Any suggestions? What do we do here?
So
Sorry, I
gives you
forgot
the
to-
point.
Yeah.
You do 1
So
point.
just
So if
draw
you
it.
start from that point and use that.
Yep, so now you're kind of combining
Then you'll
graphing and
Or you
this. You could do that. Or you could just plug in the values of that point and then solve for b. Okay, but if I were to graph this, this is number 3. At 2, 5, it's right there. And then I follow this slope down 6 over 1. That's going to be crazy because it's going to be a fraction. So graphing isn't the best way. I think it's actually 2 and 5, 6, but we'll figure that. Or no, we don't care about the
Yeah, that's
x's.
the x.
So that's going to go up to, let's see. Well, it's still going to be a fraction, I think.
I don't think so.
Okay,
Oh,
let's just hope for the best. So I'm just going to plug in my 5 for y and my 2 for x.
Where'd you get the 2 and 5?
Oh, that's in the problem.
point on-
So it's parallel
It
to
says the
this
problem
and
back
crosses this. Sorry,
That's where I went wrong.
I didn't put that information. That was important information. So I'm just plugging in my x and y value. So -6 times 2 plus b. So 5 equals -12 plus b. So b equals 17. Boom. So that's my intercept. So now I have my complete formula, which is y equals -6x plus 17. That's the answer. The point slope formula is a different way to do it. Here's the point slope formula. Y minus y value equals slope times x minus x
I
value.
don't like that. I like the one.
Okay, but look what happens. If you plug it in, so y minus 5 equals -6 times x minus 2. Distribute that 6, and then get rid of the 5, and you get y equals -6x. 5 added to a 12 would be 17.
Oh.
So that is quicker if you know the formula. Then you just get y by itself. But see how that kind of takes your brain out of it. You just plugging it into a formula. and just hoping for the best, hoping you don't make a math mistake. Okay, so either way works. All three of these, we graphed it, and you just follow that up to the y-axis. Where it crosses, it'll cross at 17. Okay, you guys good? All right, number, what are we? Number 7. Not as stretchy in this outfit, this ensemble.
Me? I'm scared.
Okay, number 7. Solve and classify the system. Here's what it is. 3x plus 2y equals -6. -2x plus 5y equals 23. What are the 4 different ways I could solve this system of equation? Substitution, elimination,
And the other one I don't remember.
Oh, Kramer's.
Kramer's rule with the matrices.
That one's awful. It makes me throw up in my mouth a little bit.
All right, which one looks the best?
So, wait.
The one that you
Elimination. Nope. Substitute. Nope. Which one's the one we do all the time? Substitution or
Kramer's
elimination?
rule, probably.
No, because that's required in some of the tests. But you don't have to like do
No,
that.
I like
would-
the ones where you make like 2 of them the same.
And then you add them together and they cancel.
Yeah,
That's
that's the
actually
All right.
substitution or
only-
elimination.
So substitution in this case, you would have to deal with fractions.
Okay, elimination.
Yeah, you have to get y or x by itself, but see how you either way, whatever
Ew, your
form.
hand. Why is your hand black?
Yeah, just because
They're like frostbite.
of that. But don't
So let's
touch
do
that.
elimination.
Elimination. All right. Well, right now, if I add these together, they won't eliminate. But if I multiply this by something and this by something, then we can get the same. So it looks like 6 is my least common multiple. So let's multiply this top one by 2.
Right.
And then we'll multiply the bottom one by
Tree.
3. Okay, so let's rewrite this. 6x plus 4y equals -12. And this is -6x plus 15y equals 69. Okay. All right, so add them together. Someday you will grow up.
No, why'd you say it was such like disappointment? It's fine. I bought my mom a 69 car keychain and she threw it away. That's okay.
Okay, anyway, moving on to maturity. Y equals 3, right?
You wish.
I mean, guys, come on, grow up.
Yeah, really. Can't laugh
Oh, I
at
just
69.
marked up my mom's sweater. No, it was a mask.
Wow.
It's okay.
Hold up. That's your mom's sweater?
Of course, that's where I give all my good sweaters.
Hold up. Okay, well, Gracie.
Okay, so y
So
equals
that's why it's
3.
so small.
This is nice because it just works out so beautifully. And then you can just plug. So this is, when you use substitution, it's easier on the back end and a little bit more difficult on the front end to get one of those variables by itself and plug it all in. But elimination is easy on the front end, but a little more difficult on the back end, okay? So what I'm gonna do is I'm gonna plug in 3 for y in one of these equations and then see what I get. Let's plug it into there. So I get 3x plus 6 equals -6. 3x equals -12, x equals -4. And then I just want to make sure it works in that equation too. -2 times -4 is +8, plus 15 is 23, check. So you can leave it like this, or this, you can write it like the cool kids, -4, 3. All right, how's that feel?
So we're just trying to find the y value.
We're trying to find the x and the y value. So we just found the y, and then we had to plug that 3 in for y to get the x.
Oh,
You could have plugged it into either equation, but
Right.
yeah.
Right. Sorry, I was.
Okay, moving on to number 8.
It says you.
We Refer to the equation 4x plus 2, find the intercepts. Okay, this is pretty easy. You're just setting each one to 0 and then figuring it out. So if you were to look at this on a three-dimensional plane, and doesn't make sense, three-dimensional coordinate system, then your x and y would be the same, and then you'd have this z value, z-axis. So here's y, here's x, and here's z.
Gross.
So see how that comes out of the board there, okay?
But no
But-
one likes Z. Can we like not have Z?
But here's what I want to know. I want to know where the line, this one-dimensional line, is going to cross the y-axis, the x-axis, and the z-axis. Okay? All right, so here's what you do. You just set them all to 0. So if x equals 0, hold on one second. No, sorry. So right, that's not true.
You can't just set them all to 0.
No, to find the x-axis intercept, you have to set all the other two to 0, okay? So if I set if y and z equals 0, then x, then 4x equals 20. So x would have to equal 5. So here's one intercept. X is 5,
I can't see.
0, 0. Okay, so that's
So you can
the
put that in
x-axis
5, 0, 0.
intercept. Yep, 5, 0, 0.
And then you
Okay, and then
you set like X and Y to 0 and find
Yep.
Z.
so x and z to 0 to find the y, and x and y to find the z. Yep. So if I did this, then I get y equals 10, right? Because that when you set those to 0, it's nice. You just ignore them. 2y equals 20, y equals 10. Okay, last one. Set x and y to 0, z equals 4. See how I'm getting those?
Yep. But if we
Yeah.
put those in, then it won't equal 20.
Yeah, well, every time. 4 times 5 is 20.
And we will
Plus,
put them all in.
oh, not all of them at the same time. No.
But isn't that the goal to get them
These
all
are
in?
3 different points.
No, because
Yeah.
it wants you to format it as 3 different.
Okay.
Are we gonna review this again on Tuesday? Because we're not even gonna be halfway there.
Yeah, we're gonna talk
Are
a
we
little bit
taking
more.
the test on Thursday?
We're gonna start it and then you're gonna finish it at home.
Last time that happened, I forgot about it until the very end of break. Yeah,
literally
what he's doing.
All right. Well, don't.
What your
The
brother
grades are
doing.
due Friday,
I know.
so you got to get her
That's
done.
what your brother's doing.
Okay. So change 14/5 to a percent. Oh my goodness, so easy.
I know.
So here's 9. How do you change to a percent?
By putting it into a calculator.
So, what you do
Yeah.
is divide by 14 and then multiply by 100.
14 by 5.
Well, yeah.
multiply by 100.
You-
As long as you do it
the way
right.
It's done
Yeah.
looks right now. You just do that problem and multiply by 100.
Okay, that's one way. Here's what the cool kids are doing.
Am I not smart enough for this?
So a percent
No, you're not a cool kid.
is what percent?
I don't know.
So look at
I
that.
Quit.
So 5 times 20 is 100. 14 times 20 is 280. So 280%. You don't have to do it like that. If you divide it, you get 2.8, and then just move the decimal 2 places, 280%.
Can I do it the way
But
I
see
did
what
it?
my mind
I
does?
thought you said something about multiplying it by 20. I was like,
Well, yeah, you can there. So if you do it equivalent fractions, because
oh,
you want to
'cause
know
the
what
five-
percent,
Okay, yeah, yeah.
because that's percent there. All right, good. That was number 9. Number 10 is find the additive inverse.
This was easy.
Just negate it, okay?
So you
Number
did that.
10,
These there's some of these
additive
I
inverse.
thought I was doing it wrong because they're so easy.
What if it was the multiplicative
Then you
inverse?
just like
Then
flip
you
it
just
around.
Yeah.
split it.
So add inverse of, what is that, 6r over 7?
Yep.
Negative 6r over 7. Don't do both. It's not the multiplicative, it's not the negated reciprocal. It's not the negated multiplicative inverse. It's just the additive inverse.
Yep.
Yup.
Yep. I just messed up really bad.
Okay,
You would.
I did. I would. You're right.
I messed up everything, so.
Yep. Stop.
there is one more part of my ensemble that you haven't seen yet that I'm
Oh, no.
going to reveal when we vote.
I won't be here.
You won't be here?
Can I leave?
No, I literally only take this class
That's right.
and then.
You're not gonna
physics.
stay and vote,
That's
dude?
it.
I know.
You only take 2 classes?
All you take.
That's lucky. But I also don't want to
Lucky.
take more classes at Red Box because I don't want to be like.
Okay, number 11, guys.
Next year.
These are direct variation and inverse variation. So direct variation, if I wanted to say the number of cups varies directly with the number of fluid ounces. Okay, so I'm going to say, that's kind of confusing, but so let's just say F. So see how the number of cups varies directly as the number of fluid ounces. If it was inverse variation, it'd be a division problem instead of a multiplication problem. Okay? So let's see here. Now we're going to plug in our first example. So scenario 1. Eight cups. There are 64 ounces. Okay? So let's figure out what K is. What's K? K is 1/8, right? So now we're going to plug in our 1/8 into scenario 2. Scenario 2 says, how many cups, that's a variable, are there when there's 120 fluid ounces? So 1/8 times 120. All we did was plug it into that top equation in both scenarios. Now that we know our K, because we had to use scenario 1 to figure out our K, now we can solve that. All right. What is that? How many times does 8 go into 120?
Hold up.
15 times?
Yeah, 15.
So 15 cups. It says write a proportion and cross multiply. This is actually the easier way. This is the scale factor way. So if you say the number of cups varies directly with fluid ounces, you can write your proportion like this. And look at how easy this is. We don't have to deal with K's or anything. So C1 is to F1 as C2 is to F2. Okay, so C1 was 8. F1 is 64. C2 we don't know, but F2 is 120. Look at that. Fish at home,
Fish it.
and you get 15 cups. Okay? So either way works. This is awesome. If this was inverse variation, it would be C1 is to F1 as F2 is to C2. So you just flip that second ratio. Okay? Number 12. There's pine needles on my iPad here. I don't know where they came from. There are 5 titles in a bag. Oh, 5 tiles in a bag. All right, cool. This is permutations or combinations. Let's see here. 5 tiles in a bag, labeled with the letters A, B, C, D, and E. The tiles are chosen at random from the bag without replacing them until all 5 have been removed. In how many different orders can the tiles be removed? Thank you. Okay, so without being replaced until 5 have been removed. And how many different orders can the tiles be removed? Okay, so is this a permutation or a combination? Yeah, because the order matters, right? So really, in this case, since you're going all the way, you're choosing 5, it could just be this, guys. It's just 5 factorial. 5, 4, 3, 2, 1, which is, what was that, 720 or 120? 120? Yeah. Okay. So this is in how many different orders can it be removed? So this time, so that's the key word. How many different orders? Is because you are, order does matter. So you could pick the A first or the B first or whatever. Okay. If you set it up like a permutation, it would be P of 5, 0. So remember, permutation is how many total there are, and then over 5 minus how many you're choosing. Well, this is 5. So remember what 0 factorial was? 0 factorial is 1. So 5 factorial over 1, or just 5 factorial. It's factorial. So factorial means multiply by everything underneath it. 5 times 4 times 3 times 2 times 1. Weren't you there that day when we talked about it? This is one I taught from home. Were you sleeping?
Probably.
Okay. All right. So that's number 12. I think we can do, let's do number 13 and then we'll call it a day. We're finding the least common denominator. It doesn't even say to add. It just says find the least common denominator. How boring is that? Okay, so if there weren't variables here and it was just 3 and 7, what would the least common denominator be?
1.
That's the greatest common factor.
Oh, right.
Least common denominator.
21.
21. Okay, and then the least common denominator is the biggest exponent of each factor. So you guys remember adding these? Like if I multiply this by 7 and this by 3, and then I need another couple more x's. So then you can add them like that. So you basically, what do 3 and 7 both go into? And then what do x to the 6th and x to the 4th go into? Well, actually, x to the 4th goes into x to the 6th. Because you can multiply x to the 4th times x squared to get x to the 6th. So the least common denominator is 21x to the 6th. So here's what you need to remember. Do this normally, like normal fractions. The least common denominator of 3 and 7 is 21. Okay, and then you're looking for the biggest exponent of the variables. Can you remember that? Biggest exponent, write that down if you need to. Okay, so number 14, I think we could do 14. And then we only have 6 more to do on Tuesday. What do you think?
Do we have any problem sets?
It's like 4 after. We got 2 minutes.
We can also talk about like.
I feel like it's pushing it a little bit.
All right. Gmo says no.
Black man, give me some math.